All right, welcome back everyone. We're diving right back in with part 3 of our series on the iLog rule language. This time, we're tackling another 25 must-know keywords for your IRL toolkit. So, let's get right to it.
So here's the game plan for today. We're going to build this up logically, just like you would when writing a real rule. We'll start with setting up the rule set itself, then we'll get into managing the data, and then the real fun begins, crafting rule conditions. After that, we'll see how to control which rules fire, add some extra context, and we'll wrap up with a quick heads up on an old keyword.
First things first, you've got to build the house before you can put anything inside it. This first section is all about those foundational keywords that create the container for all your rules. Before you can write any logic, you have to define the structure and figure out how data is going to flow in and out.
Now these two keywords are pretty much the pillars of any rule set file you'll create. Package is super straightforward, especially if you have a Java background. It's just about keeping things organized in a unique namespace. But initial action, now that's where things get interesting. It's this special block of code that runs just one time before any rules even get looked at. It's perfect for any setup tasks, or even just logging that your rule set has started.
Controlling how data flows in and out of your rules is, well, it's absolutely critical for getting predictable results. IRL gives you 3 really clear keywords for this. In is your look but don't touch parameter. It's read-only. Out is for when your rule set needs to create something brand new and send it back. And in-out is the real workhorse. It lets you bring an object in, modify it, and pass the updated version back out. Picking the right one makes your code's intention crystal clear.
Okay, so our rule set structure is in place. What's next? Well, we need to give it some data to actually work with. This section is all about what we call facts, the actual data your rules will chew on and how we get them into the engine's working memory.
A fact in your rules action block has a pretty clear 3-step lifecycle. First, you use new to create an object, just like you would in Java. But here's the catch. The engine has no idea it exists yet. That's where insert comes in. You're explicitly telling the engine, hey, pay attention to this. And this last step, this is the one that trips people up all the time. If you change that object, you have to wrap it in a modify block. Seriously, forgetting this is a classic bug that'll have you pulling your hair out.
Okay, but what if you don't want just one fact? You want all of them. That's exactly what instances is for. It's a super simple function that just scans the working memory, grabs every single fact of a certain type, and hands them to you in a nice, neat list. It's incredibly handy for when you need to do things in bulk. All right, we've got our container, we've got our data. Now it's time for the fun part, the actual logic. This section is all about the keywords that build the conditional when part of your rule. This is really the brains of the whole operation. You know, we already saw in when we talked about parameters, but it's a real powerhouse in your rule conditions too. It's just such a clean, elegant way to check if a value is part of a collection. Instead of writing a bunch of OR statements, you can just ask, hey, is this city in our list of major hubs? It just makes your code so much easier to read.
You know, sometimes the most important condition is checking for something that isn't there. And that's exactly what the not keyword is for. It lets you write rules that fire only when a certain type of fact doesn't exist. This example here is perfect. This rule will only activate if there's not a single person over the age of 50 in our data.
Ah, the dreaded null value, a challenge for every developer, right? Well, IRL gives you 2 super clear keywords to handle this safely. IsKnown is your safety check. You use it to make sure a value is actually there before you try to do something with it. And IsUnknown is for when you're actively hunting for missing data, so you can flag a record for an update.
Okay, let's rapid fire 3 more useful keywords for your conditions. Instance of. If you've ever used Java, you already know this one. It just checks an object's type. Occurs in is a bit more specialized. It's for complex event processing, like asking, did this event happen during this other event? And finally, literal is just the fancy term for any hard-coded value. You know, the number 5 or the text, hello.
Okay, now for a really important topic. What happens when things get complicated? What happens when the conditions for multiple rules are all true at the exact same time? The engine has to make a choice about which one runs first. This section is all about how you can control that choice.
Yeah, this is the big question, right? When a bunch of rules are all screaming, pick me, who actually wins? If a customer qualifies for both a standard discount and a special VIP discount, which one should they get? You can't just leave that up to chance.
And honestly, the simplest way to solve this is with just a number.
A plain old number. You use it to tell the engine, hey, see this rule? It's more important than that other one.
And that number gets assigned using the priority keyword. It's super simple. You just add it to your rule, give it a value, and that's it. The rule with the highest number always goes first. It's a really straightforward and effective way to manage the execution flow.
But what if you need more fine-grained control? Well, you've got other tools in your belt. Ordering is for when you need a strict sequence, like Rule A must run before Rule B, no exceptions. And overrides is perfect for that discount scenario we talked about. It's a way to just flat out declare that the VIP discount rule always beats the standard one if they both apply. No numbers needed.
We are in the home stretch now. This next section is less about the nitty-gritty logic and more about adding useful information to your rules, and this part is cool, peeking inside the engine to see what it's doing while it's running.
I love this one. Think of the property keyword like digital sticky notes for your code. You can attach any kind of metadata you can think of, the author's name, a version number, a quick description of what the rule does. This is fantastic for documentation and keeping things organized, especially on big projects.
All right, for the power users out there, these two keywords let you really peek under the hood. Match gives you an object that's full of details about the current rule that's firing. Matched classes goes even deeper, telling you exactly which types of facts triggered the rule in the first place. These are absolute lifesavers for deep debugging or building detailed audit trails.
And finally, let's wrap up with a quick public service announcement. You know, as with any technology, things evolve. So let's talk about a keyword you might stumble across in older code bases, but one you should definitely avoid using in anything new.
It's always good to know the history, right? Especially if you're maintaining code that's been around for a while. But for anything you're building today, it's so important to use the modern, supported ways of doing things. It's all about efficiency and making your life easier down the road. So you may encounter this keyword called logical. Way back when, it was tied to a pretty complex way the engine managed facts. But here's the only thing you really need to know about it today. It's deprecated. Don't use it. Modern rule engines are way more efficient and handle the stuff differently now, so just steer clear. And that's a wrap. We've just powered through another 25 IRL keywords, from building the rule set to managing the data and controlling the execution flow. At the end of the day, all these keywords are just tools. They're the tools that let you take complex business policies and turn them into smart, automated decisions. So the real question is, what amazing business problem are you going to go solve first?